what should I do here? You know what? I'll write it up at the top. Sorry, I need to make up my mind. I'm going to write it up here. So this is for collision 2 to 3. Okay, now and remember what we said. We said that the final velocity of cart 2 is equal to the initial velocity of cart 2 going into the next collision, right? So let's write that down. Let's say that for collision 2 or 3, we're going to say that initial velocity of 2 equals, I'm going to use the decimal 1.33 VO. Okay, and the initial velocity of object 3, well, we can see that it's at rest, so that's going to be 0, which again lets us use a shortened version of these equations. So let's find the final velocity of 2. Now, this is the final velocity of cart 2, but we're treating it like it's object 1. Like right down here, we're going to be using the exact same equation as this right here because it's the initial object going into the collision. Don't be confused by the fact that we say it really is cart 2, but it's the first object that has velocity in that second collision right there. Okay, so the final velocity of that is, I'm going to write the m's as m2 minus m3 because we're dealing with this cart and this cart here. So instead of m1 and m2, we're dealing with m2 and m3. So I'm trying to keep all my subscripts uniform. Divided by m2 plus m3, right? All that times the initial velocity of object 2. So that simplifies to 2m minus m over 2m plus m times the initial velocity, times the initial velocity of object 2, which is 1.33 VO. I'm definitely going to be running out of space here, but that's all right. Let's simplify these out. That's going to be, let's factor out the m's here. M times 2 minus 1 times 1.33 VO. Really squeeze that in. Over m times 2 plus 1. Okay, well, the m's go away. 2 minus 1 and 2 plus 1, that's about as basic arithmetic as you can get. That is going to simplify to 1 over 3 times that initial velocity of object 2, times 1.33 VO. Okay? So 1.33 divided by 3, you could actually do this a number of different ways. What I'm going to do is I'm just going to divide 1.33 divided by 3. That equals 0.439 times that initial velocity right here. Okay? So that's our final answer for the final velocity of cart 2. And let's see if I can squeeze the last one in right here. Final velocity of 3 is what? Well, remember, 3 is the second object, or it's the second cart in this collision. So we're going to apply solving for the final velocity of the second object right here. So that is going to be 2 times that first object, which is object 2, over m2 plus m3, all that times the initial velocity of object 2. Okay. Simplifies to 2 times, what's the mass of cart 2? 2m divided by the mass of cart 2, 2m plus the mass of cart 3 plus m. And let's plug in the initial velocity of object 2 in this collision, 1.33 VO. Simplify, so that would be 4m over 3m times 1.33 VO. And again, if our m's cancel out, which they will, that's simply going to be equal to 4/3 times 1.33 VO. Let's just simply combine them and multiply them together. That should give us an answer of 1.77 times that very initial velocity, whatever it is. Okay, so that's the final velocity of cart 3. After cart 1 hit cart 2, and then cart 2 hit cart 3. So I hope this method has at least given you an idea of the importance of making sure your subscripts and all your labels are correct. But here we have finished up part A right here. Find the speed of each cart. Find the final speed of each cart after each collision. There you go, part A. Look for me again on part B and part C, where we verify conservation of momentum and kinetic energy. See you then.